All right. Let's see if this is going to work. I'm sharing my whiteboard and I'm going to now write Coulomb's law. The electric force equals K Q1 Q2 over R squared. Now where should I be looking? Or is this going to be my video? I don't know. Let's erase all that. Change this a little bit. Let's try again. So one of the problems that some of you, I don't know where to look, but one of the problems some of you had an issue with was in the second ed puzzle, having to calculate for R, being that it was in the denominator. So just real quickly, I'm going to write Coulomb's law here. And I am going to just set it up with the information that you were given. 6.0 times 10 to the negative fourth, it's a negative. 9 times 10 to the ninth, and as usual, I am leaving off my units for the sake of space here. It did mention that each charge was identical, and that the amount of charge was 2 times 10 to the negative 10 Coulomb, so we'll write that twice, and we are trying to solve for R squared. All right. On the shape, I want to really select. Oh well. All right, so the first thing we need to do, obviously, when we have something in the denominator, is get that joker up out of the denominator. So I'm going to multiply both sides by R squared. All right, that will bring, whoops, that will bring the R squared over here with the 6, period, times 10 negative 4. And then I'm just going to multiply these the three things in the numerator together. And when I multiply those three things together in the numerator, I get 3.6 times 10 to the negative 9. Those would be some really weird units, by the way, because the K, the Coulomb's constant, is crazy complicated units. But ultimately, all of these units combined, we're solving for R. All of the units will cancel out except for meters. Okay, so here, as you can clearly see, I'm going to go on to the next slide and kind of start over. So we're left with this. I'm so sorry. Equals 3.6 times 10 negative 9. We're going to divide both sides by the 6 times 10 to the negative fourth. Now, when you do this, you've got scientific notation and you're dividing by it. Make sure you're either using the E key or you're keeping everything in parentheses as you should. And if you do it properly and you divide, you'll find out that R squared is 6 times 10 to the negative 6. If we had kept up with all of our units, that would now be meters squared. So then clearly I'm just going to take the square root of both sides. R is going to equal, without scientific notation, 245 meters, or in scientific notation, R is going to equal 2.45 times 10 to the negative third meter. And 10 to the negative third is the same as saying 2.45 millimeters. And that's that problem worked out. Hope that helped.